So we are going to be working through 6K from the Unit 1 and 2 Cambridge Methods textbook, which is focusing on understanding the bisection method. So the bisection method is just another way of finding the x-intercepts, but we do this through estimating. So as we do this, if we are unable to calculate the x-intercepts. Okay, so the main thing that we need to be thinking about here is we understand that there is going to be an intercept when there is a sign change, hence a root has occurred. So let's go through this. So I've just got two graphs here, and we can see if I pick A and B and I times them together, I've got a positive and a negative, so it's just going to give me a negative. Likewise with my second graph. It's, if I pick point A and B, I'm still going to get a negative, which means that I have a root. And we can see here we've got three roots between A and B, whereas that first graph we've only got one. So this is where we can use it in terms of we get closer and closer until they practically meet, and we are just estimating that value. So first thing we need to be thinking about is we need to pick an interval and a sign change exists. So f of a times f of b is always going to be less than zero, and that means there is a root between them. We will then calculate the midpoint. We'll evaluate that point in the function, and then we're going to determine again our 2 points that we're going to use. And that will be based on if those 2 points are less than zero. So let's have a look at this. So we have x to the power of 3 plus x squared plus x, take away 5 is equal to 0. Has a root between x equals 1 and x is equal to 2. And we're going to use the bisection method twice to find an approximation of the root. So the first thing we need to be thinking about is we need to evaluate for when x is 1. So I substitute 1 into my equation, and that will give me negative 2. Then I look at the next x value, and I substitute 2 in for x, and I'm going to get 9. If I times those two values together, it gives me a number less than 0. Therefore, there is a root between them. So the next part is we are going to find the midpoint of those. We know the midpoint of 1 and 2 is 1.5, but the equation is we add them up, we divide it by 2, and we get 1.5. Now we are using 1.5 as our value that we substitute into our equation, and we solve for it. That gives me a positive. So we need to follow this rule that we are timesing f of a times f of b, and it should give us less than 0, which means there's a root. So because of 2.125 is positive, I need to look for the one that is gives me a negative, which is 1. So that means my new interval now is going to be looking at between 1 and 1.5. We keep repeating these steps. So again, to find the midpoint, I'm just going to add 1 and 1.5 together, and I'm going to half it, and we know that's going to give us 1.25. I'm then going to evaluate and substitute the 1.25 into my equation and find out the value. So that value is negative 0.234. So based on this, being it's negative, we will be using this value. We can keep repeating this if we would like to. So just make sure you know that we are able to repeat it multiple times. Now, the interval that we have available now is looking at 1.25, which is a negative, and we needed the positive one, which is 2.125. So those are my 2 points that I'm going to look at. So we know x is going to be greater than 1.25, and we know x is going to be less than 1.5. Now, with us estimating, and based on our answer here of our y value being negative 0.234 compared to it being 2.1, we can quite easily see that it is going to be closer to 1.25. So let's do this again. We'll just do one more question. Same steps are going to apply. So we have a function of y equals x to the power of 3 plus 3x plus 6, showing roots that lie between x equals negative 2 and x equals negative 1. So the first thing every single time we need to do is we need to evaluate to find out our y value. So I'll substitute negative 1 into my equation and I get 2. I'm going to then substitute negative 2 into my equation, and I'm going to get negative 8. The next step is we are going to calculate the midpoint of these two values. But before I do that, I'm just going to double check. But I could see that this is positive and this is negative, so it's going to give me an answer of less than 0, which just means that there will be a x-intercept. So with the midpoint, I'm adding my two x values together and then dividing by 2. Negative 1 plus negative 2 is negative 3. Divided by 2 is negative 1.5. So we evaluate this again. We put negative 1 is negative 1.5 into my equation and I solve it, which gives me negative 1.875. From this, we need to determine the new interval that is going to give us less than 0. So we need one negative, one positive. We have to use this midpoint, which is negative. So the other one that gives us a positive is negative 1. So we know it's going to be between negative 1.5 and negative 1. So we are going to repeat these steps. We already know this. I'm just re-putting that information on the 2 points we've picked onto this page. We will look at the midpoint again. I'm picking easy x values at the moment. So we've got negative 1 plus negative 1.5 and halving it. We already know it's going to be negative 1.25. We evaluate again. So we substitute our negative 1.25 as our x value into our equation and we get 0.29. 6875. Let's double check on what the interval will be. So here we've got a positive. So that means we are going to need a negative, and that means we're using negative 1.5. So we've got our two values. We know it's going to be between these two. Same thing, we can, from this, we can go that next step and go, what is it closest to? So negative 1.5 gives us negative 1.875. That negative 1.25 gives us 0.29. So 0.29 is closer to 0, which means our x-intercept will be closer to negative 1.25. Now, with what we've done here, an easy way of doing this, everything I've done, I could do it in a spreadsheet. So I could just put the left endpoint, the right endpoint, the midpoint, and then f of m. So substituting that value into my equation. Then I've got again, because that's negative, I'm picking negative 1.5 and negative 1, and I've got the midpoint, and I'm working out what that function of M is. So be mindful, this is an easier way, a nicer way to put it, but it's not showing all your working out. So you need to make sure you have written down before what is our A value when we substitute -2 in, what is your -1 value on the side. If this helps you, it will make it easier for us.